So my understanding is that cloud computing is the interconnection of devices that are far apart, not directly linked to one another.
Okay. So I don't know if you can see the image that is there on the picture right now.
Yes, I am.
So we've got this provider being able to provide browse telephone users. They can provide IVR services. We've got another cloud there that is able to provide other services, another browser. So these are all infrastructure that are already available, but they are able to process services. Remember before this, we used to call what I'm sure you must have heard of software as a service, software or hardware as a service, software as a service, platform as a service. You've heard of such, before that?
Yes.
You are there?
Sorry, my network was bad. Come again.
Okay. There's been where in the past, in between, I think in the recent past, there used to be where we are used to say software as a service, platform as a service, infrastructure as a service. It continued to whatever. But ideally, what we are trying to say is there are some kind of infrastructure available somewhere that you can use, because your current system, where you are, your residential there, you may not have enough either memory, you may not have enough either the processing rate, the processing speed is very low, is very small. So it's better to use other processors that can help you to get immediate information or results. So there is some infrastructure somewhere in a remote area where you can access. There is some data centers elsewhere. There is some computer processing machines that could be, you can rent from and be able to. So we have this customer who can enjoy services from some area, somewhere, where we have now what? We are now trying to have Zoom services. The Zoom platform, I have no idea on what data center they use. Is it Zoom themselves, they've got data center, or they're using Google, they are renting elsewhere? So, in short, cloud processing, cloud computing, some kind of processing happening in some distant or remote areas. However, helping us, who cannot afford to have all the data centers in our own house, our servers, bigger machines in our remote, in our home. So basically, that's what I can simply say. I'm sure, like I've said, platform as a service is some kind of machine able to process things at higher speed for you to appreciate. So, like right now, Zoom that we are using is basically we are using cloud services elsewhere. So Facebook, they've got a number of data centers elsewhere and so forth and so on, but we are able to access services. However, we may not exactly know where they are even located, and how you can access to such services. How are you accessing such services? The better I can actually say is somewhere in the cloud happening. So the Flickrs, MySpace, or YouTube, and so many and so forth and so on. So all these are services, all these are infrastructure that are happening, but apparently they are connected to make an international network. So they are vast, and very robust computer system that is able to process at a faster rate. Take, for instance, allow me first. Take, for instance, just an example, please allow me. You are there?
Yes, Doc, we are here.
Mm. I don't know if you can see this.
Yes, we can.
Have you seen the definition just there, cloud computing?
Yes.
I don't know if it's similar to what I was trying to, the thing that I able to explain.
Yeah, it's just the same.
It's
The
some kind
process
of
of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or a personal computer.
I have a laptop right now. The speed of processing is very slow. The memory space is there, it's very slow. That's why sometimes I even avoid to record. Right now, most of the institutions, they're asking you to store certain, even pictures. So into some cloud, instead of having everything happening here, I was saying in between, I don't know which years I can say, we talked about infrastructure as a service, software as a service. Instead of you having antivirus on your machine, you can still download it. Or right now we've got 365.
Yes, yes, yes.
So the 365 sits on Microsoft base, the Microsoft servers, but you can access already an updated version and everything. You just have to be connected. But how you are connected, no one knows. Is there a fiber in between and what have you? But what I'm trying to say is, I've just Googled cloud computing, but all these pages, they are all sitting somewhere. But how many, in those few seconds I Googled, how many pages have come? And in how many seconds? I don't know if you can see here.
Yes, 479 million within
So
0.49 seconds.
these are servers elsewhere and what have you, but are we able to tell where exactly they are located? But how long has it taken us to access them? But where are they? Where are they? You can go even to so many pages, how many pages that are there. So the best thing, the easiest way to say is somewhere in the cloud.
Okay.
Where the computer machine is sitting is somewhere in a remote area, but is able to process it and provide you services there and then in an instant. So how else can we? So now, moving forward, while we are able to receive such answers, such results, there is indeed some connection to all these, but which server is it sitting? It could be sitting at Facebook, it could be sitting in Europe, it could be sitting in Africa, it can be sitting. However, we are still able to connect to this because why computer networking? They are connected to the computer network. The computer network is able to help us connect to all the servers that are distant, where we may not even imagine where they are, in which country they could be, and be able to download even video, even just type in Simon Tembo, you are going to see how many servers are going to respond. So why computer networking? The idea basically is to share the infrastructure. The idea basically is to share the infrastructure. There are some rich countries, rich companies that can manage to put up even update infrastructure almost on a 3 years period, even annually. There are some institutions, maybe like my employer who may not be able to update such infrastructure or such computer systems, but there are certainly institutions that are in the habit of not maybe not the habit, but in the business of providing services that needs to be shared. So Google, for instance, Microsoft, for instance, they are able to do software, develop software, and they want this software people to access them, but they still have to pay. So, and they are able to update this very software, and us we just wake up and see that just like even the telephone, the DSTV that we have, there are people, Microsoft themselves, that don't know, sorry, my mouth choice. They are able to update the schedules of their TV programs, timetable and so forth. They develop the timetable, the programs, even maybe is it 3 months in advance, or is it 1 month or 2 months, 3 months, 4? So you find that you want a movie that you want to watch, but in a near future. So the question is, how the timetable has been made possible? Is it in for 24 hours or 48 hours or 72 hours? So much knows better the capacity that they have to process the timetable, the schedule of movies on every channel that you have. Mnet 1, Mnet 2, Mnet 3. So there is already a video programs that they've done, maybe 24 hours. I think if you agree with me, maybe not 24 hours, maybe 7 days. Try that to check on one channel to check
Actually, it's 8 days.
8 days, so which is about 1 week. So they've
Yes.
got in their library, they're able to do the schedule of that. The question is, why can't they do more than 8 days? It's again something to do with processing and processing speed and the memory. However, the question, the point we are trying to talk about, the computer network is there for us to be able to share. How do we share? By switching. What type of switching? The old one, the legacy one, circuit switching. The latest one, packet switching. The internet that we've come to know, the packet switching has made it very possible for us to be able to do that. How was it this thing came about? Through what is called best effort services, adopted from the mail system. So the internet is based on the best effort service. We explain more on that. So the mail system, the postal system, whereas the package protocol, how do we package the protocol? How do we package the packet? How do we do the packaging of the packet, the package or the information itself? To talk, for instance, of eggs, how should we pack the eggs? How do we pack the breakable things? How do we pack fresh things that can go bad for not being protected or not being put in some freezers? So all this type of packaging becomes very important. So the idea is what parameters should we use? The size, the weight, the content. These are the things that the post system they've been using. How to transport such kind of information or such kind of packets or contents. What is the size? If you are trying to use DHL or FedEx, they'll ask you, what's the size of your item you're trying to ship? What's the weight? What are the contents? If it's breakable, what kind of wrapping should they use? What kind of package should they use? It's the same thing that is in their network as well. The size, the weight, the content of the information. The address, where is it coming from? Where are you situated, sir? Where are you situated, madam? Where you want to transport these things? They've got to know where the message is coming from and where it's supposed to be taken. Then they will decide the delivery process. And then the type of transportation. So this comes from the postal system, which helps us to come up with the packaging, what is being sent, where is it going, where it's coming from, and how best can we route it. And so such information provided, then we'll be able to come up with what kind of application are we talking, what type of food transportation should we use, which network should we use, and the data link and then physical layer. This is the TCP IP type of protocol coming from the OSI 7 layers. We'll go in detail on this, but ideally this whole thing came from the postal. Why? We are trying to share the infrastructure because I'll talk about the N squared problem, avoiding the N squared, everyone to be connected at the same time. I mean, everyone, if you're trying to connect, talking to all the members of your family, they need to have a direct link to them, to you, which is not possible. So as we prepare a packet ready for sending, we get to add addresses for each layer. Addresses for each layer. We are going to discuss the issues to do with the addresses for each layer and why. The whole idea is for us to be able to know which application are we. If I go to Google, Google of its own, the port number. Every browser, they've got their own port numbers. Every application that is there on the internet, they've got their own port number on which the services have to go through. The whole port number is part of the addresses. The particular addresses that should be how the packet is going to be identified. We need to have the source and the destination addresses coming from the mail system. So it is borrowed computer network, despite being built so perfectly well, working this much in such few seconds. But while the post system, if we are to say, trying to send something or trying to look for something, it may take us years, maybe for what we will go to within less than 50 seconds, we're able to collect so much millions. In terms of the postal system, we will not be able to do that. However, going forward, oh, please, I beg your pardon, you have to use the same login details to log in. Eh? So the data we have from that, we say we need to know the content of what are we writing. So later go from who, where is it going, where is it coming, until it's delivered. So ideally, until the data is composed, then the address is going to be appended, an address from where it's coming from to who it's going to, and then we'll know what delivery system should it be. Is it by sea, is it by air, or is it then by that the destination, how should it be delivered, by scooter or by just a man walking along the road? So this is later on what came from who? The IP, TCP. The application layer, the data, the transport layer, the IP, the IP or network layer, and the physical layer. So in this course, we'll discuss the UTP, TCP, and transport layer, and a few application layer, we are going to discuss them. And then on the network layer, we are going to talk about the IP address, the IP, the network layer, sorry, the network layer, and then we'll talk about the physical layer. So that came from the postal system. In terms of the OSI, we have got 7 protocols, you go upside down, application layer, presentation layer, and session layer. These 3 constitute the application layer for the TCP IP. The session layer, presentation layer, and application layer constitute the application layer for the TCP. Thereafter, I've got transport layer, network layer, data link layer, and the physical layer in that manner. Whereas the switch has got only 2 layers, and the router has got only 3 layers. like that. Don't forget this. The switch got 2 layers, the router's got 3 layers. The router goes to operate up to the network layer, the switch up to the data link layer. Whereas the host like your cell phone, the laptop, who have all these layers. So at the end of the network, so here this could still constitute part of the network. The network layer may have only physical, 2 layers or 3 layers until we reach the server or the device, your cell phone, your laptop, you name them, TV, that may have all the application there where to be able to sort the services that you are enjoying.
Okay, Doc, I have a question.
Please.
Doc,
How about the layer 3 switches? I think you've heard of them, huh?
There may be some layer 3 switches. I would say it's just an improved version. Otherwise, the whole idea is trying to make them operate as a router. So, in my own opinion, I would just call it just a router in a way, but operating. So, may I put it simply this way? You are there? Hello?
yes.
Yes, Doc, I'm there.
Remember, we used to have 2G, then came
Yes,
3G,
Lord.
then
Yes,
came
Doc.
4G.
Yes,
So,
yes.
in the beginning, there used to be only the one antenna for 2G. Then the 3G came, they had to add additional antenna. A 2G antenna standing alone on its own, and the 3G antenna comes standing alone. The 4G came. Then they say, wait a minute. The tower, can it suspend, can it manage to have all its weight? Why don't we put all the antennas in one bar? The 2G, the 3G, the 2G on the bottom, the 3G in the middle, and the 4G. So ideally, research has been there to improve on what is existing. So a router can also be given the function, can also have a function to operate as a switch. Are we together?
Yes, Doc.
So go to the operator, you're going to find that actually an antenna may have actually even the 5G antenna. The thing that they have, the one on the base stations. So they're supposed to have 3 sectors, 60, whatever. Eh? So
Yes.
instead of putting separate antennas for these technologies, 2G, 3G, 4G, so they will just put one bar, which is going to have all those antennas inside.
Okay, Doc.
So, going forward, traditional topics, the layering, the internet architecture, routing, transport, queue management, and the name domain systems. However, we've even gone beyond this. There will be now recent topics. Now we are even discussing artificial intelligence and so forth and so on, and cybersecurity. But in terms of this course, the broadcasting, routing, mobility, we've got now mobile internet, the active networks, quality of service, security, network management. So there are various topics, various discussions that are ongoing, which you can still use for you yourself who wants to do, which type of research you should do, you dive in, which makes your blood flow in your veins. Which topic are you looking at? So going forward, we've had the computer evolution, starting mainframe, computer, PC, desktop, and now mobile internet, and we are still moving on. There is more, and and the whole thing is just becoming more and more interesting. It all depends on which part of the future you want to participate in, which type of this. I think we've already passed this 2020. So how do you participate into these computer evolutions? What devices are you looking at? So computer communication, we have the sender and the receiver. There must be a sender and a receiver with something to share via a message to facilitate communication. However, there has to be a medium or a channel that must exist between the sender and the receiver where messages should travel. So the protocol, procedures, or rules or standards must be followed by computers when sending or receiving data. So it can be a server, it can be anything, or what we are saying, the protocol and procedures, the layers that we have talked about. So basically, what we are saying is from the basic principle that you read at the undergraduate, it continues. Where I've got a transmitter and the receiver and the channel in between and the modulation and everything that is going to happen, the processing, so forth and so on. However, the most important thing that I've said here is we are trying to share the infrastructure. And why? Because of the N squared problem. It's coming. Wait for it, it's coming. So networks needs to be differentiated by saying what architecture are we going to use, the peer-to-peer or client server? Like the one that we are enjoying right now is a client server. We are using Zoom, some server where it's sitting somewhere in front of you and some program that is running on some machine. But otherwise, we are using client server. We are the client, and there should be a server somewhere where we are accessing to be able to share. Then there will be a topology. Is it a bus, the star, a ring, hybrid, or wireless, or combined? The protocol, Ethernet, TCP, or IP. The media, coaxial, twisted, or fiber optic. That is helping us to connect to all this infrastructure that we are using. Like I said, use the same login system, right? Login numbers, details I gave you. So what's a protocol? It's a standard that specifies the format of data as well as the rules to be followed during transmission. Interoperability is what is very important. All of us will got different